Okay, this is Mr. Weideman, Lafayette High School, Functions in Trigonometry class. We started our section on exponential functions, and we ran out of time today, so I'm going to do a little bit of recap and then get on to some of the new material we mixed. We talked about exponential functions, and we got to this guy where we had this funny number called the natural base, and it's this irrational 2.72 number that goes on forever. And we're going to get more about its magical properties and why we use this number later on in this chapter. But for right now, we're just letting you know what it is. What does the graph look like? For our purposes, we're going to use 2.72 in our calculations, but if we want to graph this without using a calculator, we're going to approximate it with 3. And it's going to, for the range that we're going to do, the domain that we're going to do, it's actually going to be really close. All right, and then we went on and I believe we made a graph of that, of the parent function, approximating e with about 3. And we made our parent function just like we did as if the base was anything else. Okay, nothing real magic there. Then we gone on in here and we have some useful exponential functions. What are exponential functions used for? Well, one of them we use for is what we call our compound interest equation. And this is really just sort of a plug and chug, okay? Principal times our base times n times t. And these are what all of these little things mean. The only hard part about these particular problems is plugging your information into the correct part of the equation, all right? And that's what this is for. And this might not make much sense until we actually work a problem, because the only one that's really obvious is the principal. The other ones, and usually the time period is pretty obvious. The other one we need to do a little bit more investigation. One particular example is interest rates are almost always given as a percent value. And we need to put it in our equation as a decimal. So that typically means that we're going to take our percent value, divide it by 100, and then that is the number that we're actually going to plug into our equation. All right, let's go through a typical example problem. And they give us some values here. And we've got to plug that into our equation, but what goes where? Well, we got two scenarios. One, they're going to say, let's compound at a rate of 8% annually for 5 years. So n annually is going to be once per year. So we're going to plug in n is equal to 1 time per year. All right, what if they said we're going to repeat the problem and we're going to compound it quarterly? That means 4 times per year. So we're going to enter 4 into our equation. All right, so let's do the computation here, first with n equal 1, then n equal 4. Okay, so the first part is the amount, and there's our principal, 10,000. Be very careful how we write that base. Remember on the previous slide how we wrote the base, okay? And if you remember from the previous slide, okay, this base was 1 plus the interest rate. I think, what do we use? Small r divided by 1. And in this case, our r is 8% divided by 100. And that's where we got the 0.08. Compounded once per year. There's my n value for a total of 5 years. And then you literally put this into your calculator. Don't try to shove it in all at once. You'll more than likely get it wrong. Usually, if I was going to put this into a calculator, the first thing I would do is I would compute this garbage. If you wanted to put it in your calculator and make sure you got it correct, this should work. You should be able to put 10,000, an open parentheses, a 1 plus 0.08 slash 1, and then use your caret symbol, parentheses, 1 times 5. And you go, well, that's just 5. Well, that's correct for this problem, and that will work. Okay? Now, if you do that, it'll pay attention to order operations correctly, and I think you'll be okay. All right, let's practice doing this. Slightly different values. Okay, our n changes to 4, so our principal is the same. Our interest rate is the same. N belongs there in our denominator in that part. 4 times 5, plug and chug into your calculator, and you can see you get a slightly better deal if you compound more often. Okay, so again, plug and chug. You just have to practice these a little bit and know what number goes in where. Okay, now there's another type of problem, and the key word here is for the rate at which you compound. It's not annually, it's not quarterly, it is something that we call continuous compounding. And that's a totally different formula. Okay, the base does not depend on the interest rate. The base does not depend on the number of times you compound, or n. N basically is infinity. So we use base E, that natural base. Okay, and again, it's just plug and chug. Okay, R is going to be the same, percentage rate divided by 100. And time period is always in years in this equation. And let's use our previous information. So I had a time period of 5 years. I had an initial principal of 1,000, interest rate of 8%. Put that all in your calculator, and you'll get a correct answer. Okay, what does that look like in your calculator buttons? 10,000 times. You have an E button in your calculator, and when you have your E button, it automatically throws in the caret symbol looking for an exponent. Be very careful. All right? If you want to do the 0.08 times 5 previously or in your head and plug it in, that's fine. Otherwise, you're going to have the parentheses. Otherwise, your calculator will do it wrong. And again, plug and chug. Just got to know what to put in where. Okay, so let's talk about our assignment. Not that. Here we go. Here's our assignment. Okay, so page 454, 35 through 31 odd are just graphing these types of problems and translating them. Okay, these guys are our interest rate problems. Okay, remember that for continuous, our formula is a little bit different. Okay, we call this the PERT equation. And then our other compounding principle, 1 plus, better check me back on this, rate, compounding times t. Okay, and that is, use this for continuous, and this one you use for compound over some interval, some time interval. All right, the word to look for here is continuous. Okay, so this should be a pretty easy assignment. Learn those plug and chugs. It's easy points on a test or a quiz. All right, thank you for your time.